Some environment news now on the programme. Mozambique and Malawi are counting the cost of Tropical Storm Freddy, which ripped through southern Africa for the second time in a month over the weekend, leaving at least 17 people in those countries dead. Now, Freddy is one of the strongest storms ever recorded in the southern hemisphere and could be the longest-lasting tropical cyclone. This is according, anyway, to the World Meteorological Organization. To tell us a bit more, Shirli Sitbon joins us from our science desk. And Shirli, how do scientists explain the strength and particularly long duration of this storm?
Well, they explain it by its structure and by its trajectory. Let's try and have a look on this. It was very long, as you said, more than 10,000 kilometers overall. It started around the Philippines. We can see it on this map. It intensified, became a cyclone level 5, intensity 5, extremely intense, and it continued to remain a cyclone even though it crossed Madagascar and also Mozambique. Then it was very erratic. It went back into the sea, picked up speed, went back both near Madagascar and Mozambique again. And this is explained, though, it's by its trajectory, because if it had been going south, well, it may have de-escalated because of the atmospheric conditions further south. But it continued on this path, and it may be a record. Scientists are now looking at this because it depends on how many days it was more than a tropical storm. Some days it was a bit not as powerful. It was less powerful, and that would be deducted from the number of days. So overall, it's been years, that scientists have been reporting and looking at these cyclones and storms for 40 years now, and this could be a new record. Extremely intense, extremely long, very slow though. That's why it picked up so much energy. Let's look at what it was like from the ISS, from the International Space Station. We can see the image from there, how they saw it from there, and it shows the structure of this cyclone. It was shaped like a ring and extremely compact. You can look at it now, and basically that shape is also one of the things that made it extremely steady. Now, you can see that image, and let's listen to a spokesperson of the World Meteorological Organization.
Freddy's traveled more than 10,000 kilometers, and it's generated accumulated cyclone energy. So that's an index that we use to measure the amount of wind energy. It's generated as much accumulated cyclone energy as an average North Atlantic hurricane season. This is one storm.
Now, Shirli, climate change, of course, a factor here. Climate change, it does make extreme weather events worse. We know that. And Africa is thought to be a continent particularly vulnerable.
Yes, and we see it once again when we look at these images of all this water pouring down on various areas hit by Freddy. Well, all this water will not go to other areas, neighboring countries where there's currently a drought. It makes things even worse. So there are more and more extreme situations, extreme weather events, and authorities are actually saying that they're preparing for this better and better. Residents have been moved to other areas, although obviously the storm was extremely erratic, but authorities actually managed to limit the number of victims, although there are victims, but the number of victims has been limited because they were moved in time. And authorities say that in all of these countries, there was a meeting in September about how to avert disasters and try to have these systems where people can be evacuated very fast.
Now, Shirli, a study by the University of Oxford shows that it's actually a combination of factors behind extreme weather events like this. So it is climate change, but not in isolation, rather combined with other factors.
Yes, many factors, and maybe I will a bit simplify it because there was an extremely interesting study that was printed in Nature that comes from Oxford. We can see a picture of that article that is available online, which shows that the rivers in the sky, we've talked about them very often. Well, all these rivers, which have more water in them than the actual rivers on land, well, they just basically hover over the areas which have all of these droughts, and they just don't stop there. They continue all the way to DRC, and then it rains where there are already forests. And there's some areas where there's this drought and other areas where there's more and more water. And this is explained not only by the current situation of climate change, which makes it more extreme, but also by extremely old situation, what's in the ground, geophysics, because what they say is that for many, many years, before even man was here and was able to, create all of the pollution, well, the fact that there is a rift, all these tectonic plates, well, it makes the areas with the droughts lower their valleys, and basically the rain does not pour there. All those rivers in the sky, they continue to other areas with different altitudes, and this explains this. So basically it's the old situation, the old problems, we can say, that are combined with new situations, with climate change that make all this extreme, and obviously all of these areas have to adapt to this very fast.
Shirli Sitbon, thanks very much indeed. Well, staying with Storm Freddy, our focus